Hello again. Today we're going to talk about rational expressions. Rational expressions are the fractions of algebra. A rational expression is an expression with the form p over q, where p and q are polynomials and q, the bottom, the denominator, is not equal to 0. Some examples of rational expressions we have x divided by x minus 3, negative p squared over p squared minus 1 are just some examples of rational expressions. When we're looking at rational expressions, one of the first things we should look at is what can we not have in the denominator. For example, in the x divided by x minus 3, we may want to make a note that x cannot be 3. Why? Because 3 would make this expression undefined. So when we're dealing with rational expressions, it's always good to note what would make the expression undefined. Similarly, in this one, negative p squared divided by p squared minus 1, you may note that if p were 1 or negative 1, then that would give us 0 in the denominator. So we would have to make a note that p cannot be plus or minus 1, because putting it in there would make that expression undefined. Now let's move on to simplifying rational expressions. If we wish to simplify a rational expression, we have to do two things. The first thing is we factor the top and bottom, if possible. And the second thing, once we factor, we look for common factors which will cancel out each other. For example, here we have an expression, simplify the expression x squared minus 9 divided by x squared plus x minus 6. So first we need to factor if we can. If we try and factor the top, x squared minus 9 factors into x plus 3 times x minus 3. And try and factor in the bottom, x squared plus x minus 6 factors into x minus 2 times x plus 3. So the expression is now factored. And now we can cancel out common factors. And we see what's common is x plus 3 and x plus 3 on the bottom. So those factors actually divide out to become 1. So what we're left with is x minus 3 divided by x minus 2. Now, as stated before, you always have to make note on your rational expression what makes the denominator undefined. What makes the denominator 0, which makes the expression undefined. And we will see if I put 2 in here, that would make the expression undefined. So x cannot be 2. In addition, we actually have to look at the expression before we simplified it, and looking at this x plus 3 here in my expression before simplification, I note that x, if it were negative 3, that would also make this 0 on the bottom. So x cannot be negative 3 either. Even though we're simplified it, we still have to look back to see if x were negative 3, this expression would be undefined. And so this is the simplified version, x minus 3 divided by x minus 2, is the simplified version of x squared minus 9 divided by x squared plus x minus 6. Let's take another example. Here we're asked to simplify a couple expressions. Let's do the top one. We have 5x minus 5 divided by x cubed minus x. So notice on the top I can factor something, and also on the bottom. I can factor 5 out of the top, and I can factor an x squared, because x squared can go into x cubed and into itself. So I can factor an x squared from the bottom. So if we do that, we get 5 times x minus 1 divided by x squared, and when we factored out the x squared, we're left with x minus 1. Notice common factor is x minus 1. That can be cancelled with each other. They divide to make 1. And so we're left with 5 over x squared. Now we should make a note. What can x not be in this expression? Well, it can't be 0 because we can't divide by 0. So x can't be 0, but x can also can't be 1. Because in my previous expression, before I simplify, if I put 1 in here for x, we get 1 minus 1 gives me 0. So it's always good to make a note of what x cannot be. Let's do the second expression. The second expression says we want to simplify x squared plus 4x plus 4 divided by x squared plus 2x. Well, let's factor top and bottom. The top is a trinomial we have to factor, and it factors into x plus 2 times x plus 2. The bottom, we can factor out an x. So it factors into x times x plus 2. And we can cancel our common factors. What are our common factors? X plus 2. We could only cancel it with one of the x plus 2's above, like this. And so my final expression is x plus 2 divided by x. Again, we should know what x cannot be. Well, x cannot be 0, of course, because we can't divide by 0 here. And x cannot be, what would you think? Negative 2. If I put negative 2 in here for x, we get negative 2 plus 2 gives me 0. So x cannot be negative 2 either. Let's do one more example. Here we're asked to simplify the expression y minus x divided by x minus y. And they look very similar, but a little simplification can be done here. What we can do is if we factor out a negative 1 from the top, like this, we'll be left with negative 1 times negative y plus x. Multiply the negative 1 back through, we get plus y minus x, which is what the top is, divided by the bottom of x minus y. Now, why did I do that? The reason we did this is that actually the top and bottom are now exactly the same, apart from the negative 1. If I rewrite the top with the x first, we get negative 1 times x minus y divided by the bottom, which is x minus y. We now see that these factors are the same. We can cancel them out. And what are we left with? Negative 1. In fact, whenever you see two terms that are subtracted opposite from each other, top and bottom, you can actually simplify those to negative 1.